Continuing on our 6.4 lesson, we are still solving by completing the square. Sometimes though, when we are looking at completing the square, we will have an odd numbered b value in the middle here, and that might throw things off just a little bit. So I'm going to show an example of what to do in that case. So we'll set it up like we did before. We were looking just at this first piece, x squared plus 3x. We want to make that a perfect square trinomial, so we have to add something. So that's going to be x plus something squared. Well, just like before, we look at this piece and we'd say 3 divided by 2 is what's going to go into this piece. But 3 divided by 2 doesn't necessarily equal anything any more helpful. It's still just 3 halves. So we have to plug in 3 halves into this piece. Now that might be a little awkward to deal with, but that's okay. We can still work with that. That's totally fine. Remember then that it's 3 halves squared is what's going to be this piece. So 3 halves squared is going to be 9/4. So 9/4 is what we're adding to that to make it a perfect square trinomial. So we set it up the same as what we did before. X squared plus 3x plus 9/4 to make that perfect square trinomial. Same thing, whatever we do to this side of the equation, we have to do the opposite of it to keep it balanced. So minus 9/4 as well, plus 1 equals 5. So in this case, this equation is the same as this one, even though it has these 2 extra pieces here. It's the same exact equation, we just have it written a little bit differently so that we can create our perfect square trinomial here. In this case, x squared plus 3x plus 9/4 was this piece over here, and we can rewrite that as this binomial squared, x plus 3 halves squared. We still have these pieces, our minus 9/4 plus 1 equals 5. And I'm actually going to change those really quickly here into fourths because we're working with 9/4. So 1 is 4/4, and 5 is the same as 20/4. Now that we have it in fourths, we can combine these terms on this side. This is going to give us x plus 3 halves squared. That's going to be minus 5/4 equals 20/4. Now we have to add 5/4 to both sides. Gives a little more room to work. In the end, that's going to leave us with x plus 3 halves squared equals 25/4. So this is our x plus n squared plus m form. So now we say that x equals square root of our m, so square root of 25/4, minus our n value, so minus 3 halves. From here, we can reduce it down some. We can put it into square root of 25/4. Remember, it's going to be positive or negative. And the square root of 25, we can break it up into 2 pieces. Square root of 25 is going to be 5. Square root of 4 is going to be 2. So it's positive or negative 5 halves. And still minus our 3 halves. There's a little more area to work. If we're using positive 5 halves minus 3 halves, that's going to give us 2 halves, which equals 1. Or if we're using negative 5 halves minus 3 halves, that's going to give us negative 8 halves, which is the same as negative 4. So in this case, our solution set is x equals 1 or negative 4. Both are valid solutions. And again, we have to check both, positive 1 and negative 4, in our original equation here to make sure that it fits. Sometimes when we are completing the square, we'll find that it's in the form ax squared plus bx plus c, where a is not 1. So in these cases, this number out front in front of the x squared term is going to be bigger than 1. Normally that might scare us away, but we're pretty confident in our skills. We know what we need to do. We can just take this entire piece and divide it by 3. Why did I pick 3? Is because that's what that a value in front of the x squared is. When we divide each of them by 3, or if we divide the whole thing by 3, it's like dividing each of them by 3. So it would be 3x squared over 3 plus 2x over 3 plus 1 over 3 equals 7 over 3. That's totally legal. We can do that. When we do that, that's going to give us x squared plus 2/3 x plus 1/3 equals 7/3. So now we have a much easier trinomial to work with. And we do the same thing that we've done before. We look at the first part here, our x squared plus 2/3 x plus something to make it a perfect square trinomial. And we know that it's going to be x plus something squared is the perfect square binomial that we're trying to create. Remember that this piece divided by 2, so the 2/3 divided by 2 is what's going to go right here. 2/3 divided by 2, anytime you divide something, it's the same as multiplying by the reciprocal. So we could say that as 2/3 times 1/2, in which case that's going to give us, you can either say 2 over 6, or you can just reduce it down to 1/3. So 1/3 is the value that we're going to put in right there. Then remember, we take this piece here, our 1/3. This piece squared is what's going to go in the end here. It's our c value. So that's going to give us 1/9. So we'd say that we're adding 1/9 to create that perfect square trinomial. So change everything up to x squared plus 2/3 x plus that 1/9. We also have to subtract that 1/9. Do the same thing, or should I say the opposite thing to the same side. Plus 1/3 equals 7/3. Since we did the same thing here, canceled each other out, so it's like we didn't actually even change the equation. But we can look at this piece, focus just on that, and say that we have x plus 1/3 squared. You got that from over here, minus our 1/9 still, plus our 1/3, which I want to change to ninths. 1/3 in ninths is the same as 3/9, and 7/3 in ninths is the same as saying 21/9. So now we have everything in a common denominator. Combine these like terms. That gives us x plus 1/3 squared plus 2/9 equals 21/9. And now we just need to get rid of the 2/9 on each side here. So we have x plus 1/3 squared equals 19/9. Now we have it in a form of x plus n squared equals m. So we look at our m and say that x equals square root of m minus our n value, so minus 1/3. And actually, if we want to break this up, this would become square root of 19 over square root of 9 minus 1/3. Oops, 1/3. Now from here, remember, anytime you take a square root, it can be positive or negative value. So we'd say that x equals positive or negative 19. We can't really change that any. Over, you could say positive or negative, but let's just do this one in 3, because 3 is going to be the square root of 9, plus when we have it as 3 in the bottom here, we can now combine these. We have our 1/3 over here. We can combine these into 1 and just say then that from this form we'd say x equals -1 plus or minus square root of 19 all over 3. So in this case, this is our final answer then. It's going to be either, if we wanted to write it as 2, we'd say -1 plus root 19 over 3, or -1 minus root 19 over 3. So you could either write it this way where it has the plus or minus, or you could do this way where you have plus or minus. Either way, they say the same thing. So this is, like I said, a case where our a value out in front is not 1. We've got one more example here. This is when we get to the end and we have complex solutions. So you can't necessarily tell just by looking at this one that it's going to have complex solutions, but when we get to the end, then we'll encounter that, and I'll show you how that goes. So we start the same way we do with any of them. We look at our x squared plus 2x plus something gives us a perfect square. So that's going to be x plus something is a perfect square binomial. Remember, this value, so our 2 divided by 2, which equals 1, that's what goes here. So we have x plus 1 squared. Then we say that our value from there, 1 squared, which equals 1, that's what goes here. So we had to add 1 to make that a perfect square trinomial. So x squared plus 2x plus 1, what we got from over here, minus 1 to keep it all balanced, plus 3 equals 0. That's what we got from here. This piece now, again, is our perfect square binomial, so x plus 1 squared. We still have minus 1 plus 3 equals 0. Now from here, combine these like terms. X plus 1 squared plus 2, -1 and positive 3 gives a positive 2 equals 0. And we need to subtract 2 from both sides, so we have x plus 1 squared equals -2. Thus far, it looks pretty darn similar to our x plus n squared equals m form, except for the fact that this time our m value is negative. So we'd have to say that x equals square root of -2, and then again still minus our n value, minus 1. So in this case, when we simplify this down, x equals plus or minus square root 2. Remember, whenever there's a negative, we'd say I. So plus or minus the square root of 2 times I. Or if you wanted to write that another way, you could say, we'll give us some more room down here, we'd say x equals I plus or minus I root 2. But each of those still has to subtract 1. So if you wanted to write it as, again, in the positive or negative form, you'd say plus or minus I roots of 2 minus 1. Or you could write it as x equals positive I root 2 minus 1, or x equals negative I root 2 minus 1. Again, both ways are acceptable. This is if you do positive or negative in front of the I. This is if you do a positive or negative. You can do either one. Both will work. At this point now, we've gone over all of the completing the square terms. If you have any questions, don't hesitate to ask. Otherwise, stay golden, Byron High.